As a friendly reminder, there is a playback speed button built right into the YouTube player, so if you find yourself not wanting to sit through a whole hour and something minute video in real time and you want to speed through it, go ahead and increase that speed. What's up everyone, it's Ryan here, and today I have a special announcement that I am going to be selling, and they're now in black, so starting today on the black PCB. These are the original PCBs that have been circulating. You know, I have a bunch of these units out in the wild now, and now is your time. If you're a do-it-yourselfer, you can go ahead and build the exact same thing. You still have the options in here for the original 1S, the Toshiba 1S 1588, and basically all the same gizmos. Nothing's different. You are still able to, if you want, on the do-it-yourself crowd, to put WEMA capacitors instead of these greenies in here. Every one of these I've made to date includes the greenies. So if you heard a tone demo that you really enjoyed, it's 99.9% likely going to have the greenies in here. So I am making these circuit boards available, and they will come to you basically in a box, a really nice box, and they looked like this, which is mostly populated, as you can see. Just a few more things that you can buy based on your needs. So if you're good with a soldering iron, and even if you're just starting out, this is a very easy project. That was kind of my goal, is that it minimizes the amount of times that you have to touch the soldering iron and to learn how to solder on that. And also, because by popular demand, the Valve Screamer and the Tone Geek, and to separate out yours from mine and for you to have some pride to it, I have new faceplates made here, and they're the same faceplates that I'm using. Let's see if I can focus on it. They're the same faceplates that I'm using on the through-hole. So I do have a 100% through-hole option as a circuit board as well for you. They both come with this built by, but designed by, the Tone Geek on here, which is kind of cool. Yeah, and I give all the instructions and the drill templates on my website, so you don't have to touch your drill at all, or even own a drill, because I give you all the coordinates and Tata does the drilling for you, where to source the switches. Like literally, you can build yourself without any sort of labor markup 100% of the Tone Geek's Valve Screamer TS10. It's just another way that I'm sort of giving to the community for those who want to start, and there's no weight on these. I have about 20 something of them right now. My plan is to just keep on pumping these out, while the whole builds are going to be a lot slower, because they're, you know, for me, more labor intensive and getting parts in and all that stuff, and based on my own schedule, doing some cool things behind me I'm trying to work on. It's all, you know, very exciting, but I also want to make sure that you guys are still getting a good flow of products for those who want to buy stuff and have the tone, chasing the tone. Okay, so right on my website, and I'm going to right now, for those who have bought the kit and want to go through the instructions on how to build one of these, I'm going to be doing a full real-time build starting right now. All right, so this is the first video that I'm taking of the TS10, and I'm going to do a do-it-yourself sort of approach on this one. I'm going to sell these boards. So some folks wanted the surface mount version, the original version that I was circulating before Cheerio Tone took over the through-hole version and requested a through-hole version 100%. Some people wanted the original with the metal film resistors and such, and you could technically do that with the through-hole version, but you know, there's, I don't know, some validity to the original. And plus, if you're somewhat of a beginner when it comes to building pedals, you can see that a lot of the components are already installed. So less, you know, soldering on your part, and more consistency, quicker to assemble, and quicker to get to the end result, which is some awesome TS10 style tones. So I'm going to kind of walk you through it, and just, you know, how I build these. And I'm going to start, and you don't have to. So on my BOM, I have some substitutions This is a Toshiba, a new old stock Toshiba 1S1588, and you can, it's the same, you know, in my tests and on the data sheets, it's the same forward voltage as your typical 1N914s or the 1N4148s. So if the one place online that you have to pay a bunch of shipping for has these, and you're sort of weighing that when it comes to the overall cost of your unit, I wouldn't stress about it too much. So just stick with the alternatives and you'll be fine. Tata Electronics has the alternatives as well. But, you know, go ahead and you can make that decision yourself. There is an improvement I've made. So if you look at gut shots of this one with the black circuit boards versus the original, the only thing that I've really done here is I've surface mount designed in the diodes for the Boss BD2 clipping, as well as, well, no, just the Boss BD2 style clipping in here, the asymmetrical. That's the Keeley mod, by the way. So I'm gonna get these in. I'm gonna find some more parts so I can start assembling the rest. And just for reference, this is what the 1N 4148s and or the 914s look like typically. Alright, next up I'm going to do the red LEDs. This is for the soft clipping mode, which overall this pedal is soft clipping entirely. But I don't know, it's got higher headroom. It's basically the softest clipping. How about that? It gives you the highest headroom, most touch dynamics. Alright, so one thing you're going to notice here is that there's a flat spot on this silk screen, and that flat spot corresponds, and hopefully you can see it as I rotate this. See that little flat bit right up here? It kind of shines in the light. That's going to correspond with the flat side. So as I rotate it, see it's flat, I'm going to rotate it like this. And that's going to be the shorter of the two leads. So now you see the long lead is positive, the shorter is negative. So I'm going to do that on both of them. And I designed this board so it would be easier to assemble with the LEDs pointing the same way. So if you make a mistake, it's likely going to be that you made a mistake twice. And that because the long leads are going the wrong way, or the short leads. And guess what? Did I actually make a mistake right now on camera? Yes, I did. And then just underneath, what I'm doing is bending these leads, not aggressively, because that could cause other issues, as you might find out, but just a little bit. And I really like the circuit board holder. I put a link in the description below for you, so you can order one yourself. I like it because you can rotate it, you can use all different types of boards. What I like to do is, you know, have these things pretty much upside down and then do some soldering, and all the components seem to stay in place, or levitate a little bit just based on, you know, moving the boards. Alright, so for capacitors, I have a couple different options in this design. You're going to see that in the BOM there's like the high quality alternative, and then there's the original parts. Just so you know, pretty much to date of making this video, I've only made these TS10s with, so if you see like demos and stuff online, it's only with these capacitors. They're the greenies. They're more representative of the Mylar film that were used in the original TS10 versus like the WEMA capacitors. These are great capacitors, and I use them a lot with my builds, and they're more or less theoretically like the Nordvanc, or just like a normal transparent, more transparent tone, if that's a thing. I don't know. Some people like the high quality nature of these, and the PCB design accommodates for the 5mm spacing for these leads. They fit perfectly in here, and you're gonna see, along the way here that there's some capacitor markings where this is a surface mount component that's been removed, and you'll see the 2XX above it. It's because the original design of this board accommodated 100% surface mount. And then after that, I sort of decided, well, I want to make this kind of expandable, and whatever, if I continue to make them, or if I make them available for do-it-yourself crowd, which obviously I am, I want to give them some flexibility into these capacitors, because as you read and read and read, you get deeper down the rabbit hole of capacitors and how they change the tone, what's a good capacitor versus one that's not so good, and into pedal modding and things like that. And plus, it would be kind of an interesting test if you made 2 of these and built them using, you know, one with all. And I have some folks who have done this, and they have their own opinion on the results. But, you know, go the high quality, air quotes, variant versus the original sort of nasally compressed tone, or whatever words to describe it, of the greenies. So in this build, I'm just going to go with my original design. And, you know, if you see, like, Tomo has one of these, he has the greenie version of it. So if you like his tone, or have seen his Instagram tone demos, and I think he's coming out with a YouTube demo of it too, which is pretty cool. They're all with the greenies. Yeah, so I'm just going to install these anywhere that basically I need. What are these? These are 0.1, so I'm going to look around. That's a non-polarized, so that's not it, not it. 22 NF, not it, not it. Okay, here we go. I like to orient the face, the ones that have the markings on it like that, to the right. And what is to the right? I don't know. In this case, I'm putting it down. You're going to notice that the leads don't exactly fit in here, and that's because these lead spacing is designed really for the WEMA capacitor, the 5mm, and I believe that these are 6mm. So they kind of don't fit perfect, and that's okay. For this design, you know, I had to sort of make some choices along the way. So there's one there, and there's one here, and they sort of fit the same, as you're going to see. Oops, I'm going to turn this around. So it fits my visual ideology. Oh man, I'm having fun with this. And if you do go with the WEMA, the one capacitor that I did not change here is this C16. And the reason for that C16 is the original has a electrolytic it is polarized, a polarized electrolytic 10UF on the output here. So I maintain that in this design. If you are going to go with the WEMA, which would go in this slot here, you remove this capacitor very carefully. You see the 2 solder pads on the side, heat them up, you know, pop it off to the side, pull it, but be very careful that you're not pulling up the traces underneath. So you got to add some heat to it. Or another trick folks use is that you actually put your soldering iron on the top here. This eventually will heat up the whole entire body and will remove that all at one sweep when you push a little bit on there. So I'm going with the original sort of approach on this, and the ones that you've seen online, and what a great way to start. And also you save a couple pennies by using the greenies over the WEMA capacitors. So all those things for you to consider as you're making this. Alright, here's our 22 nanofarad. Little greenies again. We can put in the WEMA if you go that route. Coincidentally, this is perfect. It's 5mm spacing, so you're going to see this just drop right in. Whoops. And it will stay there. Going to bend the leads out just like so, and we're ready to move on to some other things. Alright, so next is 1 microfarad non-polarized. You hear at the NP, non-polarized capacitors. I use these per the original, And if you read online about the theoretical non-polarized versus polarized versus using a film capacitor like a WEMA, those little red ones, I do allow for the red ones to be used here. Again, you're going after more of the Nordvang version of the TS10, which is kind of cool. It may sound different, it may not, I don't know. I have my own opinions, and those who have some of their own opinions who have built both of these. But if you read online, theoretically, these non-polarized capacitors, these 1 microfarad, in the signal, so there's a signal on one side and a signal on the other. The only way that signal is going to get through is through this device. So that's why folks say it makes a difference on the tone and the reaction and the characteristics of these capacitors versus the film capacitors. Some say that this will give that nasally tone to the TS10. So some insight in here and saves you a bunch of reading. I've done way too much reading on the subject, and that's what I walked away with as far as conclusions. So there is no right or wrong way of these non-polarized capacitors because that's the nature of it. Make sure you get it in the right hole. It's for the 2mm, or I can't remember if it's 2mm or 2.5mm. What I do like to do, because that's just my design approach, is have the leads and the casing go the same way on this board. So I'll use the longer lead at the top, slide that in. Same way over here, I'll do the longer lead on the top, just for a visual sort of design, and just, I don't know, I like to be thorough that way. And I'm going to go over here and add, where is it? I'm going to do it to the right. I'm going to put the longer lead to the right on that one. This is where it becomes a little interesting when you start flipping the board and soldering, because as you can see, these things don't really stay still. But when you flip it entirely 180 degrees, they sort of gravity takes over. But as you can see, even with gravity, it will, depending on how you bent these leads, maybe pull the component to one side or the other. And then you can see there's sort of traffic jam situation that you get into with your soldering iron. So some folks will take one component at a time, and if you're new to soldering, I would recommend do one component at a time, solder it, clip using your clippers, which these are my preference. They're flush mount, so that means that you can cut flush against the surface. On the back here, there's no bevel. So do one component and then just clip it off. I'll do that maybe now. Yeah, maybe now. Alright, so for solder, we have this Keister 6040 solder. It does contain lead, so don't chew on it or have loved ones chew on it, animals, pets. The smoke from that's created from this, you want to circulate with a fan of sorts, or just don't inhale. Everyone has a mask nowadays, so pick up your mask and put them on for best practice. Do as I say, not as I do. But I have this in my description below, this exact kind. I bought it off of Amazon. It is definitely the best solder for this sort of stuff. It's got a flux inside, so it cleans the surface real nice when it heats up, which is great, and it just it does really well. And the flux, you don't need to clean it off, but if you do want to clean off the flux, because some people are very thorough like that, this is what I use, the Craig products, and I'll have the description below. Wash, flux wash, cleans and remove, blah blah blah. You can read all about that in the link in the description. For this, if you have a digital soldering iron, so I have a link in the description below for my preference for a digital soldering iron. I set mine at 670 degrees Fahrenheit for the solder, and it seems to work really well for melting the solder and stuff like that. So just going to flip these around. I'm going to go vertical as best I can. It may not be the best for the camera angle. However, yeah, I'll do what I can for the videos. This is my solder tip cleaner. I like to use these kind with little brass inserts because that will not cool down the soldering tip when I'm cleaning it, okay? If I use some people use water and a paper towel, and I admit I've for the longest time used water and a paper towel for soldering, and it would cool down the tip, and if you don't have a good soldering iron station, it may take a minute for that temperature to rise back to melting point. I like 670 degrees on here for this solder because it seems to melt when I want it to, and it doesn't last long at that temperature, meaning the liquid state of the solder is not so hot that it's going to destroy components, the circuit board, or anything like that. It just seems to be the right temperature. And I even use, I use a Weller. Since I do this a lot, I thought it was worth the investment. The Weller has a little bit lighter of a soldering tip, or a little bit soldering iron to hold in your hand, which gives it a little bit better control. Some of the cheaper ones, and I don't know, I don't have first-hand experience with the one that I'm recommending, but on specs and on paper it looks like to be a good deal. That one seems to be a pretty light handle too, in the description, so that would be a good one. But just be aware that there's basically the weight of the handle could affect, long-term holding these things, ergonomic, things like that. So I'm doing my best with a camera sitting directly in front of where I would be normally, so I can solder these. You can see me sort of navigating the length of my soldering pencil wire, to heat up the elements, trying to get that around to the best spot so I can melt the solder. I just hit it really quick. I try to get the pad too, by the way, because you want to get the pad and you want to leave it on there for a second. That way the solder will drop into the hole or the via, or whatever you want to call it. Because if you go too quick, it may just make a cold solder joint. You might hear a thing called cold soldering, because that way, it just isn't making a great contact. It actually could create some resistance. And resistance, because there's a gap of sorts, can create other problems that you may not like, because that solder joint is not acting as a solid soldering joint with zero resistance. It could have some resistance and some capacitance, and then you're going to have a lot of troubles. I couldn't figure out which adjective I wanted to use there when it comes to that circuit. And then you need to troubleshoot, and that's a whole nother fun lesson. So what I'm going to do now is just see if anything looks like a cold solder joint or something that could probably go deeper into the hole and just tap that. Normally I don't have to do this, but since I'm doing a YouTube video with a camera in front of my face, it's kind of hard to see. So I'm just going to go ahead and look. Just try not to be too tempted to move these capacitors after they've been soldered. And why I say that, and unless you're being very careful that you're moving from side to side and not forward, front and back, like in that example. See how you might be tempted to move these so it looks better. The best way to do that is just take your soldering iron in between the two leads and try to get them both at the same time and then move it. And the reason for that is because you can actually take that lead right out of the component if it's in place and you try to move it to a better visual look. You can ruin that component and have all sorts of problems. So just be careful, and if you are going to be anal and want to move these to match your visual likings, try to just kind of like what I'm doing here, solder both at the same time and then move accordingly. Move it very carefully to the side. Now we have a straight capacitor that are all kind of uniform in look. Another thing you can do is you can see how much solder came through the hole. So after it's been upside down and gravity's sort of done its thing, you can see if the solder has drawn all the way up. It's not entirely essential to have the solder draw all the way up. I like to show a little bit of solder, so you can see here that this component, the solder didn't absorb all the way to the top, but I do see that it filled the hole. And then back here, this joint actually did fill up and come all the way through to the top. So that's, you know, sort of what I shoot for, but it's not essential. This is all good to go. And what I'm going to do now, and it helps if you have a garbage below you, is that you would take this whole circuit board out, put it in the garbage, not because you did a bad job, but when you clip these leads, you sort of want to minimize the projectiles coming from when you clip this. Watch. Clip it, and then these things will fly all over the place in your room, and you will run the risk of having these ruin your day if one of these leads got into another project of yours, or if you step on it, if you have carpeted floor and these just sit right and you're walking without shoes, you can really get hurt that way. Yeah, not good. Don't ask. And then if you do work on electronics a lot and have, like I do with amplifiers, you know, high voltage tube amps sitting behind me, one of these flying into that tube amp could be devastating and potentially deathly. That's not good. I don't want to see any of my viewers get hurt. So you can see that I'm just going, I'm cutting them pretty flush, and not getting so low that I could run the risk of cutting the actual circuit board, but I'm just kind of running like this, snapping. I like these pliers a lot, these clippers, because they do get nice and flush. They're low profile. Yeah, they're pretty good. They lasted me a long time too, so I've cut a lot of things with them. You can see I probably need to get a new one soon because there's a hole in between from something that I clipped that was a little bit harder surface than these clippers were actually meant for. So I'll be putting a new order. Alright, so we're moving right along here. Alright, so next up we have the JRC4558 chip, and you can see in my hand I have one. You'll notice that there's a little notch on this picture of the chip where it goes, and that is where the top here would be oriented. So it's going to go into the slots like this. One tip is like these, well, okay, two things. So you can either socket the chip, so you can experiment with different chips, or if you're just going to drop it in, you may have a little trouble doing that flat. So what I like to do, and let's see if I can do the camera, is, I don't know if it's as common accepted, but I learned this in school, which is also questionable if they were teaching it correctly. But I sort of take the leads and I press down just ever so gently so they're all uniform and a little bit straighter than the kind of the fanned out that they were originally out of the box. So now that they're a little bit straighter, you can see it like this, we should have an easier time putting it in the hole. And that is what she said. You can see it just drops right in there. And you see the little dot on top. And what I'm going to do is just with my finger, I'm just going to push out, not a lot. Again, you don't really want to fan these out, these leads, when you're going through, because you could touch other components and short out. Because see how close these ones are? You know, that could cause problems if you bend them towards each other and such. So for soldering, we're going to go very slowly, and we only want to do like 2 pins at a time because you don't want this chip to heat up. I have ruined a chip before because of excess heat, and that was basically the last time that's ever happened. Is you do it once, especially if you have to desolder one of these, you will never do it again. Alright, I have my soldering iron up to temperature, and I have my chip ready to be soldered. Now again, you want to not spend a lot of time here, so pay attention to how quickly I'm going to just watch that solder drop in the hole, and I'm going to move on to the opposite corner. And if you ever change the wheels on your car, you're going to, notice the pattern. Basically, it's just, this corner, that corner, and then from that corner to that corner, kind of putting on your lug nuts sort of thing. I'm just doing that because of the spacing of the pins and hopefully taking the heat and minimizing the temperature of that chip. And if you did have more components installed before you clip them all, now is a good time to just keep on working on other components, soldering them, and then come back to this chip. Ooh. So again, your goal is to not heat up the chip a lot. Some people, if this is your first time, go ahead and get a socket, and then you don't have to worry about heating up the chip a lot. It depends. If I have a pedal that I'm experimenting with, I will put a socket in, specifically a Milmax. Or if I'm just building pedals, kind of like how my whole run here and selling them, or if I just know a pedal is the way I want it to be, I don't want to experiment, I'll skip the socket and just go straight for soldering directly. Another reason for that is that you have a little better of a mechanical connection with the chip to the board, and that will prevent any issues. I did have an issue once where the chip, because once you install it, it's sort of upside down, right? And if you stomp on this thing enough, you could loosen a chip. It's happened. It happened to a buddy of mine for a build that I did for him, and luckily the solution was just push that chip in a little bit more, and we were good to go. Just like this chip, we are good to go. Alright, next up is we're going to be filling in these Q3 and Q4 with 2 SK118s. And these are what were used on the original TS10. These are new old stock, you can see on the strip here. You don't need these, so if you're going to order all from like Tata Electronics, an alternative part number, which was used in the TS9, and I think I've even seen them being used on the TS808s, is 2SK30As. So that's a good alternative. That will be in my bill of materials as well. You might find them a little cheaper, actually. So I'm just going to go ahead and cut them off the reel here. One downside to using new old stock components is that sometimes the leads are corroded. Our flux has cleaner in it, so that's good. But some of them do not. So that's one of the reasons why I prefer the flux that I use. And that's why. Alright, so we got one installed. The other one's coming up. So pay attention to the flat side, the flat side, and which way that goes in, because you're going to see like a round back on the silkscreen picture below, and that's for the more curvy side of things. One thing I could have done a better job with the design of this, you're going to find out here. If you bend those leads, remember I was talking about bending leads together, you can accidentally make them touch and create a solder bridge. Well, that could happen here. See how close we have? I mean, it looks pretty at least, right? Because most let's be honest, some of you guys are building this for cool hits on Instagram. Just kidding, that's really assumptuous. We're all here to build the best tone. Absolutely. Alright, so I'm going to check to make sure underneath the board these are nice and straight-ish, the best that gravity can do. And the same thing applies to these chips. these transistors is you don't really want to hang out with your soldering iron. You kind of want to do one chip like this, make sure solder goes in the hole, make sure it's aligned like you want. I like to start with the middle and move on. So I'm going to go with the middle of both chips first. Let it go down there. I'm going to start with the middle so that way I can check alignment. These look pretty flat to me, pretty straight, so I can move on. Again, I'm going to go, we'll just call it chip number A first, and then we'll go on to chip number B in the opposite corner. And then we'll go back to chip A, and then we'll go to chip B. And if you want to see how bad or good, these will get warm. As long as you're not like, that was hot, you're usually pretty good. These don't even feel that warm to the touch. You know, again, I'm at I'm at 670 degrees with my soldering iron, and that was just a very quick hit, just enough to fill the holes. At this point, I'm just gonna cut off the leads. Again, I would do this if I wasn't on video camera right now. I'd be doing this in the middle of a trash can to make sure these leads don't fly into places that I don't want them to. So go ahead, clip them at this point. You don't really need to clip these. There's no components that are sitting underneath it. As long as the solder isn't touching anything else, you're good to go. So I'm gonna go put these clippings in the trash. Alright, there are no more components that I can see that needs to be filled on this. So the next thing we're going to do is add the wires to the board, okay? And I really am enjoying these wire strippers. I normally would use these kind, and if you have this kind, I'll put the description for these. I use these for years, and they're great. But then I started to have to cut more and more and get into tighter places. So I had this really nice Teflon aerospace grade wire from Tube Depot. It's awesome. You don't have to worry about melting. This stuff's just simply amazing. 22 gauge wire, and it can hurt your fingers after a while if you're constantly like stripping, and you know, both your hands can start hurting. This is really cool. So this is, I'll put a link in below, another Klein Tools thing. Basically you just put it in. It does accept 22 gauge wire, so you're going all the way to the edge. Make sure you get yourself a little bit of a I don't know, focus here, a little bit of a length at the end. Push down and pull all the way, and when you let go, you'll see here that the little shaving comes right off and pops off, and it flies everywhere. So just be aware of where these things are flying. But now you have a very nicely stripped wire that we will then put to length. Alright, so some of the things I like to do, and this is going to be really hard on camera, I'm going to just guesstimate some length here, and this will help you sort of decide. So I do have enclosures, and I'll have a separate video on that, how to order a enclosure and add your own drilling template for this design. I know from memory about how long I need for length, so what I do is I'll cut like one like this first. This is going to be for the 9 volt in the ground, going to the power supply, which is not very far away. So I'm going to just sort of make these up, cut here, and then I will strip both ends at this point, and then just start working one section at a time. Alright, so I got a little strip. Ooh. This guy out of the way. Hopefully this isn't like watching paint dry. And at this point I'm going to show everyone that there is a fast forward button down below. If you find this is starting to get a little slow, and tedious for you, you are able to change the playback speed. Alright, so if you're lucky, and you gotta be careful, I did over engineer the hole size here to accommodate some really thick wire for not that many milliamps of current going through this thing. But just make sure your shield does not, or the insulation does not go through the hole, because that is not a good soldering surface to transfer heat. So you can sort of stand up your board, just be careful, and then fill it in. The ground will take a little extra heat, and that is because I have the copper, basically a copper ground plane, and copper is a heat sink. So when you apply the heat, it's actually dissipating the heat, which is lowering the temperature of that spot. So that ground will take a little extra time to heat up properly to melt the solder to get it to come through the hole. So you can see here, solder is through the hole. We have a very strong mechanical connection here. And now we're going to move on to the switch. Actually, no. We're going to move on and do the input and output wiring. So just from memory, the input and output here, in and out, doesn't need to be very long. So that's kind of one of the design features, I guess, of this pedal, is I have very short lines from the jacks to the circuit board, so that minimizes any sort of internal noise, lower capacitance, cleaner tone signal, blah blah blah. So I'm just going to go ahead and sometimes the insulation does stick. Okay. You'll see once we put the pedal together. This is more than generous of a length, which is fine. What I like to do is then I'll push for the wires that I've already soldered. I like to push them out of the way. So that way, and if you cut the wire lengths the same, this will sort of stand up on its own and keep pressure in there. Like so. Kind of looks like a bug, doesn't it? Go ahead and add these. Now the grounds are going to take a little bit, are going to be a little bit longer. And that's just because of the physical location of where the grounds are on the switch. Some folks, you know, I've been noticing have been getting into kind of like the amplifier philosophy of using star grounds and 5-point grounds and all that stuff. In this pedal, I didn't go with that route. I think the grounds are pretty good. All along the sides here, you may see in the reflection these little shiny holes. And those are vias. They're called vias. And basically they're holes that are connected and soldered that reach the back of this circuit board. And there's basically grounds all on there. So that's a ground, that's a ground, that's a ground. And that's connecting the two layers together. And that minimizes capacitance. Because if you only have like one ground on this circuit board, like way up here, for some reason, if that was the case, you could create, this whole board could create basically a capacitor. And that's not so much effective or needed to be considered when doing audio design boards, but just for an extensive use, if you really wanted to get down to it and you're starting to design circuit boards and such, that's something to pay attention to. I pay attention to that quite a bit, just because I like to mash up theoretical and, you know, just be comforted knowing that I did exactly what I needed to, theoretically, for the best approach. All right, so I'm going to make this a little bit longer. It's okay to go a little bit longer. I can't really recall right now how exact I need to be with this length, but I'm pretty sure that this will cover what we need to, because the jacks will come in here and we're just going to connect to the ground. So I'm going to grab my super awesome stripper. Actually, you know what? I'm going to do blast for the past. For those that do not have the fancy stripper, I'm going to go here, and I like to just go round down and then just not put a lot of pressure on the stripper itself. And also, these strippers are starting to get a little dull, so the cutting isn't as precise as it used to be, where I could, you know, be confident putting it into the 22. Let's actually see, and then pull it, see how it doesn't really doesn't go. Time for new strippers, and that's why I bought the other ones. But as a quick workaround, just be careful that you're not fraying, and this is more obvious and more of a concern if you use cheaper wire that has thinner insulation and it's not pre-tinned, that the jacket or the insulation will get all mangled and just not do a clean cut, and that's not good. And plus, it will melt when you apply some heat. I had a buddy reach out to me. He goes, "I need new wire. I keep melting my wire, my insulation, and it smells really bad." This stuff, since it doesn't melt, it doesn't give off any aroma. I got some very concerning wire in the other day. I was helping fix something of a friend, and it smelled like sweet. I don't know, I can't explain it. It smelled like candy in a way, and I don't think wire is supposed to smell like candy, but that's what it smelled like when you heat it up, which was kind of weird. Alright, so again, these are attaching grounds, so it's going to require a little bit extra heat to get a good solder joint in, and double check your work and make sure that you got some shiny solder showing through the bottom, occasionally cleaning off your soldering tip. And then the last two wires on this, and this is by the way, doing wire stripping and stuff is the most time consuming if you're a builder, in my opinion. It's most tedious. They make machines that are very expensive that will do stripping to a particular length. And I also saw, I think it was Love My Switches. Anyway, someone did a poll on Instagram if anyone would be interested in wires that were pre-stripped, presumably using one of those machines, which is super cool. And I think the consensus was 2 inches. And I think that would cover most of what I would need. And it would be worth it to buy pre-cut 2-inch wires for this exact reason, because you can see how long I've been spending stripping and soldering wires to boards. Alright, now these are for the switch. So this design, believe it or not, incorporates the buffer. There's so many people going after true bypass, blah, blah, blah. Well, guess what? You're eliminating a lot of components by, and a lot of components that the signal travels through in the true bypass circuits. So in my opinion, that changes the tone. And if you're going to replicate something, don't make it true bypass, or at least incorporate the components in an always-on sort of situation or whatever for the signal to go through. And I haven't been able to really figure it out. I haven't really sat down and looked at how to take all the buffer components and then just force them so you don't have to use a momentary switch. But this design, just like the original, uses a momentary switch, and that momentary switch will basically ground these two connections. So for troubleshooting, you can always just take a wire and just connect these two, and then you just basically made a switch. The original TS10 uses a tactical switch, which is kind of what you see in keyboards back in the day, soft click keyboards. And so there's some challenges in finding the right switch to use in this circuit that emulates that precision of a tactical keyboard switch, membrane switch sort of thing. Okay, so now we have all of these components done. We'll grab a LED, and that's the next thing we're gonna install. Alright, you will kick yourself if you do not follow this next step and get too far. So what you're trying to do, as you see at the top here, you got the flat side, which is a negative, and it's 99.99% usually the shorter of the two. See here? I'm just going to flip, put that on the bottom, and then I'm just going to very carefully just space the leads out so that way it does not fall through the circuit board. Next, we're going to move on to the enclosure. So at this point, let's take our circuit board and put it somewhere safe. Next up, I have it's basically some prep on the enclosure. Here's the on, off, on levers from Tata Electronics. And then here is the power jack that I really like. And here is the custom pre-drilled enclosure in matte black. So if you do look at my BOM, I have drilling coordinates on there from Tata, and then basically just type it, you add the drilling service on Tata's website, and then after you place your order, you get an order number, and that order number you add to that. Basically there's a little app that they have on the website that you add some coordinates, and those coordinates I give you free of charge. Even if you're not building one of these, you can still use the coordinates if you want for your own builds. Share sort of share with the community a little tips and tricks along the way. So what I'm all about. And then, a couple days, weeks later, you get a enclosure pre-drilled, and this thing is a lifesaver, and plus the precision is exactly what you want. So first thing you got to do is install the jack, or the power jack. Nothing fancy. I like these really small, low profile ones. They don't need to be bigger. There's no battery installed on this design. So yeah, you don't have to worry about anything. So first thing you do, you pop it in. The long lead is on the right side and the short is on the left. And then take your nut here. It may be hard to get a like a rocket socket if you have rocket sockets. It might be hard to get in there. So what I actually do is I will take like needle nose pliers or something, and then just very carefully. You don't want to go too much because you'll actually strip the plastic on the threads. The plastic threads are part of the body. So as long as it's pretty tight, you're usually pretty good. Another tip, another trick I like to share is go to Target or whatever, order online, clear nail polish, and you can use this as sort of a glue, or you can use hot glue. But that's a little trick that some amp builders will do to keep basically like tamper proof, or for high vibration environments that will lock the nuts from spinning out. So I just spent 3 minutes talking about a single power jack. Hope you appreciate that. So if you guys order from me, well, actually, I don't know where else you would get these, but if you order the circuit board, it does come with a faceplate already, and it says built by, your name, designed by the Tone Geek. I would recommend that you get, I bought these off of Amazon, basically paint pens, white paint pen if you want, and then you can write your name down here and, proudly show that you made this pedal. Since I'm making this pedal, I'm going to use my original faceplates that are a little bit more streamlined, but the overall look at a quick glance is they're exactly the same. Alright, so now is a good time if you have some sort of fabric or something to put down, because we are going to be, basically moving these things around a lot when we're installing components. I also need to remember if I drilled everything out accordingly. I think I did on this particular batch. So I did do some corrections for folks building this for the first time. Before we do that, now that this sort of dried a little bit, what you do need to do, because the pot will touch very ever so gently, take your needle nose pliers and then just bend this out 90 degrees, like so. And then that will make sure that the pot doesn't touch the power connector, because that is the positive. Because if that power connector touches the pot and melts together, you'll create a short. So that's just one little design feature, we'll call it, that you need to take into consideration. Next up is I'm going to just install these 3 position switches. They do come like fully kind of assembled like this. What I like to do is take it all apart, put one of these nuts back on. You don't have to go nuts putting on the nuts. Wow, that was a bad joke. And then I'm going to flip this upside down. So see this washer? I'm going to flip it upside down, find the keyhole, because these are keyed. Where are you? Oh, definitely not over there. Put that upside down so that way it's not biting in. You see sort of what I did there? It's upside down. Then I will add the lock washer. I like to aesthetically have this key facing downward. So we're going to pop it up through, and then loosely attach the nut on the top. You can see that the whole faceplate swivel or moves side to side, and that's a good thing. We want to do that, or have that, because we're going to do a loose fit across the board before we tighten anything down. It is a world of pain to move something around after something's been locked down. You can't remember which one is locked down. It's just a pain. So I'm going to go ahead on this one, add the same. And another reason why I add kind of the washers like this, some people may not, it's not required, but this will have, since you're putting basically the circuit board against this body, you're going to have a nice, the circuit board is going to be against this body. It's going to be flat. And and it just gives a nice spacing, a nice surface. So when you see the circuit board inside, it's going to be perfectly aligned with this line. And see how this line and then this line would be perfect? It's just going to look nice sitting in the circuit board, or in the enclosure. And then once you box it up, no one's going to see it. But, going that nth degree in case someone does open it up, or you're just like me and I just like knowing that I did everything that I could to make it as nice as I could the first time, taking, my time, being patient, which is something that I've definitely learned over the years. It does not come naturally to me. and it has lots of favorable outcomes for paying attention and going slow. It's hard. I want to rush through this stuff. I'm excited all the time. But then I do make a lot of mistakes when I do that. So just be careful when you lay that down. So you should be able to rotate these a little bit side to side. All right, next up is the pots. They do make you work a little bit for these pots. I ordered a bunch in a bag, so they don't come assembled. So they're separate bags. Yay for these things. Since I like to keep, sort of numbers together, I could reuse these washers and stuff for others, for the other pots, but I don't want to do that because there's a specific amount of these per the pots that I ordered, and I don't want to come up short one day and not remember why or how. So I'm going to individually take the washers that came in each bag. All right, one thing you're going to know, and I think that this is being phased out, is see the little notch here? This is great if you have a chassis design that accommodates this little hole here. We do not. And what basically that does is it prevents rotation on the inside here. Maybe I probably could just design that in. It depends on how thick it is. It may not. Yeah, it could cause problems with the faceplate. So I'm not going to do that, actually. But what you do is you take your needle nose pliers and just simply grab, twist, and pull. I think I learned that in school once. For self-defense. Alright, so pay attention here. You're going to grab your circuit board. The circuit board does lay down like this, right? And it tells you at the top here what pot to use. Now this says tone 20W, and that is W20K on here. So we're going to go in the middle. Some people like to add the pot now. I do not. I do not recommend it. And I'll show you why. It does pay off in the end. So a little frustration will be actually a good thing later on. Basically, I don't like to solder anything in place, create that mechanical connection until everything's in place. Because what happens is once you start torquing things down with that's been soldered, you could crack the solder, or you can crack the component because it's too stiff. And not only the component, you could crack the circuit board, which I've seen and have done before. Not good. All right, so next up I got the 500K pot here. I'm gonna double check that they gave me the right one. I'm gonna take out the washer. All right, I fast forwarded so you guys don't have to see me struggle finding a washer. All right, gonna grab, twist, and pull A500. Where does the A500 go, you may ask? Well, let's find out. Oh, blurry, 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 been drinking too much. All right, A500, this is the drive. So if I was to place this circuit board in, it would go like that. So don't do what I would do, look over here and say, okay, well, the drive. And then it's the drive over here. No, no, no. Pay attention. Drive. Flip it. Where's my finger? There it is. Goes here. Loosely add it. There is a kind of a smoother side and there's a rougher side. Smoother side is on top. And I think, or at least this is what I found, it does help me when it comes to installing the pots or the knobs, because it has a smoother surface to ride on and it doesn't get, you know, like when you're turning it, it's rough, smooth, rough, smooth, as it's going along. Alright, next up is the last one, which is the level, 100K. Alright, grab, twist, and pull. One day I'll grow up. And double check, B100, level B100, 100K, B, same thing. And that goes here on the left. Alright, left. Alright, now it's starting to come together. Hey, look, we're almost done. And the best part is that you built it yourself. How cool is that? Alright, so let's just double check. Alright, at this point, I think I'm pretty happy. And now let's install the foot switch. Alright, the foot switch. This is a momentary foot switch. You see the M on the side. And then if you order from Tata, they do also, I don't have one with me right now, but it's a momentary that's red epoxy on the back. It basically looks the same as this switch. It clicks a little bit different. This is an alpha pot, and I've been having the most luck with this. Again, we're sort of emulating the membrane tactical momentary switch that simply it's just shorting out these two pins very quickly, and then goes back to normal, and that's what does the flip-flop circuit and allows the bypass and or signal to go through the distortion circuit using a flip-flop circuit, maintaining the original sort of design and approach. What I do recommend, and this is gonna add your cost a little bit, I recommend getting 2 of these. And the reason for that is, I don't know why, but some folks are having issues, including myself, by the way, with these switches just not working correctly, or after a while they stop performing consistently, I will say. And this is, again, very small percentage. But if you do order from Tata, order 2 of these. I'll put the link in the BOM. And if you order these alpha ones, which are sort of my preferred, I had the best luck with. Order 2 of them from Small Bear. They do have other momentary switches out there, like full size, and I don't know. I haven't been able to get that switching to work. Basically, it's creating some chatter when it slaps the connection down. So basically it's a quick open and close when you let go. It's creating some electrical chatter, and that's causing the flip-flop circuit to be unreliable. So that's not good, right? So that, anyway, long story short, order 2 of these switches. These are the most reliable that I found. And if you do have any issues, it may be because of what I mentioned. Alright, so for putting this together, I just very, hand tightened down that. I'm going to take my lock washer, which is not this one, put it here, and the keyway is facing down in this design. Lucky you guys. It goes right in there. My dog is sleeping and he's making weird noises. But my original design, I need to drill it out. I didn't put it big enough. So, in case you wondered where did I go in that last shot, but you are going to be all fine because it fits right in. Boop. And if you're getting in any sort of building of sorts, I highly recommend you getting a step bit. This is a Makita step bit. I'll put a link in the description below. But it makes anything. So I just had to ream this out real quick. I use this one drill bit, basically leave it on here permanently on that. But now I'm back in action, and I'm gonna put the keyway facing downward. So again, see it when it pops up. I'm gonna keyway facing downward, like that. And what that's also going to do is help the positioning. So momentary switches like this one, have basically two available functions to you. There's normally open and then there's normally closed. We want the normally opened portion of the switch, which means that the top, basically it's the top here. So if the key's on the bottom, the top switch, and the exact same function. This side and this side is the normally open side of that switch. So at this point, I don't like to crank down too hard, but we do have to, tighten it. All right, big shout out to my friend online, Chris, who 3D printed, how cool is that, these rocket sockets of his own design. I'm not sure if he's going to make these to sell, but they are also commercially available on Love My Switches from Pepper's Pedals, I believe his handle is. And those are equally cool. The good advantage of these is that you don't have to worry about basically ruining the finish of your beautiful pedal, because they're plastic and they're not going to scar anything. But you do have to be careful on how much you twist. So basically what I'm doing now is I'm just by feel getting the switch to be square. You don't have to crank this down either, but see how it's nice and square. Make sure the keyway is facing forward this way, which it is. And now we're getting there. We're getting there. Don't worry. Alright, so before I begin this next part, try not to get too frustrated watching me. And if you ever built one of these before, you're gonna have probably your own approach to it. And there is more than one approach. But now is the time when we're gonna take this circuit board and align all these holes so they drop in here. So you're going to see some struggles, you're going to see some pains, you're going to have some tears probably. No one gets it right on the first try. And I'm going to try to do a good job. But to save you some pain and agony, I'm going to teach you something else. So we're going to just tighten these guys up a little bit. On the inside here, you're going to take your needle nose pliers and squeeze the ends of these bad boys, so they're creating like a pointy tip, which basically is going to make it easier to align onto the circuit board. I haven't found a PC pin equivalent of these switches. If you do know of any, let me know, because this will save me a bunch of time and I can update my BOM. So if you're watching this video and I have a PC pin product in my BOM, it's because someone came through, or I found the PC pin equivalent somewhere and it's economical for us to buy them. Alright, so now we're going to guide this board. I try to tilt a little bit for the top to come through, and you may have to bend some of the pins. Oh, we're getting close. It's kind of like bingo. It's like, what do we need to change in order to get this? And again, I do have an advantage. This is why I do this, is because it makes it better. At least for me, I feel better when when I solder. So I don't like to pre-solder anything if I don't have to. Alright, so now we did it. We hit bingo. And that wasn't too hard. That wasn't too bad, right? So we are going to push down, make sure that the pins are coming through mostly on the switches. And you can also kind of gauge on how good you're doing based on the flatness. And it is going to basically, you can rock a little bit on here. But as long as you have some exposure, and you're only going to have a little bit of exposure of the pots here, see the leads coming up, that's okay. That's what we want. At this point, what I'm going to do is actually install, see here, this is why I said this is going to be a major pain if you do it afterwards. We're going to push through the LED through the hole, so now it's sticking up. Now we want it to stick up a little bit, not too much, not all the way, but so what I'm going to do is get some distance. See here, it's sort of flat like I want it to. It's sticking out maybe a little bit too far, so at this point, you know what I'll do? Is I'll just hit this middle pin with solder and to hold that in place, and we'll continue on. Alright, we have everything kind of flat like I like right here. And I'm just going to tack in place the middle. It does require some heat and quite a bit of solder just to fill the hole. Just going to tack that in place, and then I'm going to go on the other side and do the same. Not too long, you don't want to heat up that switch too much. But now what that does is that gives us a little bit more of a stable platform. So when we adjust the height of the LED to what you like, and I like it just peeking up a little bit, not too much, just like that. Then we can solder that in place. This is going to fix the height. Of that LED. So I'm going to go ahead and clip it very carefully and take the leads. Make sure you got 2 of them and pull it out like so. Coming together. We almost have a pedal here. And at this point, what I am going to do also is just hit the middle. Okay, so here we are, kind of coming back around to why I might want to do this. See how everything's sort of in place already? If I had soldered this ahead of time, the pots, they would likely not have the right height here. They might go too far, and then what that's going to do is that's going to bend those leads and create pressure and stress on the circuit board and on the pots themselves. So that's basically the main reason why I do this. Install it all at the end versus, you know, doing it first to make it easier on, you know, assembly, pushing it into the hole. Because this is way less mechanically stressful, way less stressful. And what's kind of cool is that the tolerance, if you see there is a gap on both this side and that side, it just kind of speaks to the, you know, having everything aligned. You have, you know, high precision faceplate with the high precision drilling. Everything comes together and this thing fits in here like a glove. Alright, so the next thing I'm going to do is take my needle nose pliers. It doesn't matter which one. I mean, I'm going to have a preference because I like the cleanliness. But I'm going to take the switch and wire that up. And one of the main reasons, it does take longer for us to assemble because the 2 extra wires. But I do have a reason. Switches are mechanical, and circuit boards are thrown out every single day, create wastes in our, you know, trash transfer stations and, you know, landfills. And I think that's unnecessary, especially if it's something simple to replace and mechanical. So that's why I have these switches on a wire versus directly board mounted. And you're going to see some folks have board mounted switches that basically, if you were to, it would just take so long to fix and repair. Not a lot of people have that sort of patience. And since mechanical switches can fail a lot more likely than, you know, electrical components do, you know, they're more likely to need to be serviced down the road. And those are my reasons for having switches on wires versus PCB mounted. Alright, so I'm going to push this stuff through. Definitely be careful here. And this is why I like these dentist tools, for making sure that the connections don't hit each other. And plus they're great for kind of wrapping and holding things in place. Whoops. There we go. Not my best work, but it's the best I can do with a camera in my face. Then take these needle nose pliers and push the wires down. That's just an aesthetic thing for me. And now we're getting somewhere. We're getting very close. You can see things are coming together. If you really wanted to, you can have these leads cut to length, but this didn't come out so bad. Still looks really clean. What do you think? Alright, so now that we have basically the middle leg of each component installed, or pot, and then the switch, I'm just going to snug these up a little bit, not cranking on them. This is a size 10 using these rocket sockets from my buddy Chris. Thank you, Chris. And then a size 8 for the switches. Again, 0 sort of issues with scratching the surface here. So again, that was pretty loose. Now what I'm going to do is I will add solder to the rest of the components here. So now is a great time if you want to use the fast forward feature or the playback speed manipulator on your YouTube video. And if you just want to hang out and listen to me talk, that's cool too. Got a great face for radio right here, and a voice that's not good for either. I don't know, I'm making stuff up. I'm only on my first cup of coffee. I like watching D-Lab Electronics. He's always had some wine that he's tasting during and after his videos, which is super cool. Maybe my thing will be coffee, because the Tone Geek runs on coffee. What's my favorite? Today I know what you're gonna say. Today I had Starbucks blonde roast. Which one? I don't know. Whatever one was at the store. I'll try to be more interesting about my coffee endeavors next time. Alright, so now that I have all of the solder joints filled, I'm now going to go back and give it a little extra twist with these pots and switches, just to firm them up. When you do just have the middle, if you start cranking on it, that's not enough mechanical strength, and these pots will start twisting and create stress on the circuit board. So now I'm highly confident that this circuit board is not stressed due to mechanical issues when soldering and desoldering, or actually not desoldering, but you know, soldering and reheating and manipulating and torquing down these pots and switches. Alright, so next up, before we go any further, we are going to wire up the power jacks. And why are we doing that now? Is because once we put in the 1/4 inch here, it's going to be extremely difficult to work in that area. So we're going to do this now. again, going back to my trusty needle nose pliers, I'm going to sort of twist this wire around, and the best thing that we can do is get it in the hole. That's what she said. Or he. We need to diversify our audience here, or no one. Alright, so that gives a better mechanical connection. Just because that seems to be just on the edge of secure, I'm going to solder that in place now. Okay. Next up is the ground. You'll notice this is going to be a little bit easier because the angle at which this connects to that is a lot easier. And if the wire kind of frays like that, it's okay. You don't want to spend a lot of time in this with heat, because the jack is plastic and you can actually melt the connectors inside and distort everything and, you know, cause issues. So after that's done, I'm gonna grab my dentist tool here and sort of just hug the bottom. This Teflon, another great reason for using this Teflon cable is the basically it holds its shape, which is pretty sweet. Alright, now we're going to move on to the jacks. Before you go out, and so my preference, and some companies don't go this far, they'll just, you know, wire your jack up together. But I like to use internal tooth lock washers, and I pick these up from Home Depot. You don't have to order them online, but they're 3/4 inch size. I buy a bunch of them in bulk because, you know, I'm building pedals constantly. But if you only need a few and you're already putting an order in at Small Bear, he does sell them as well, which is kind of cool. But we are going to install it like this. And this is I recommend a stereo jack, and the reason for recommending a stereo jack is because on the inside, actually, while I have this apart, the inside there's multiple connectors and multiple touch points for that jack. So when you slide in the jack, basically you're creating a little bit more stable mechanical connection with the housing, or just, you know, basically securing that cable in the jack itself. And I'm having a hard time with this. And why that's important is I don't want the jacks to be sliding out, you know, in the middle of a performance. You know, if you accidentally hit the pedal too hard or whatever, it's going to be a little bit more solid than if it was just a regular mono jack. So even though the stereo jack does nothing for a stereo operation, it's holding the where's my thing? It's holding the actual 1/4 inch cable a little bit nicer, a little bit firmer. You can use a rocket sockets, or I have this socket wrench that I prefer, because that way I can twist down on it a little bit harder and know that I'm not going to break this. Not saying the other ones won't break, but, you know, just in case. Alright, now I'm going to move on and do the other one. And we're really close. We're 4 connections away from testing this pedal, which is pretty exciting. Now, for this, you're going to pay attention here, because that little notch indicates where the sleeve is, and that's the ground. Okay? And the way that I have the wires and my wiring diagram is such is that the that notch now is going to be on the bottom, outwards towards the bottom of the pot and into that corner, because this right here is going to be where the input is wired for the shortest distance possible in this configuration. This is actually my first build ever using the black circuit boards, which is really stinking cool. And I love the way that this thing is looking with all the black inside, and then the silver, you know, obviously with the solder connections and things like that. It's coming together really nice. What you might be able to do also, and some people do, is if you have a screwdriver or something, you can just wedge it in here, so it prevents it from rotating. It'll stop rotating eventually anyway, because once that lock washer bites in, it's not moving anywhere. So at this point, what I like to do is sort of route these cables where I want them to ultimately end up. So the ground is going to be on the upper right up here, and then just have some sort of a way of making this look pretty, of course. So I'll do the grounds first, connecting these up like so. Again, trying to get it in here. Gonna do the same down here, but this is gonna be a little difficult, and this is why I think needle nose pliers are a great thing to have around, especially if you're gonna do this more than once. You know, you can buy them cheap. I'll look online and find a recommendation for which ones would be good. These, I don't know where I bought these from. Oh, they're Exolites. Trusted brand. Feels really good in your hand too, by the way. Like, it's definitely not going to move. Or it doesn't have any sort of tolerance or wiggle. It just feels like a nice, like a really nice needle nose plier. I don't know if you caught that real quick, but I accidentally touched using the soldering iron to the insulated jacket, and it didn't melt it. That's such a high temperature jacket, it doesn't melt, especially with accidents. So, but if you use like a regular sort of wire or cheaper wire that's not high temp, that would have burnt and left a really nasty looking mark. You know what I might do is on this one, it looks like it's just going to be easier to go in like this. Come on. Sort of have the connection going inward like that. Since that's on the edge of falling out, I'm just going to tack it in place. Don't need to hold it too long. Then move on to the other. The last connection. Now there's no real way to test this in advance or on the bench. I don't know. I like to just go for it and have confidence. See, now that's going to look really nice. And well, it does look really nice. Nice and clean. I'm a sucker for the black. I think it's just a timeless look. Looking back at, you know, pedals in history. I'm not looking for like a signature color, like the Tube Screamer. But maybe black will be the signature color for my pedals that I build. Alright, so now it's ready to actually test. The last thing you want to do is just make sure that everything kind of functions. You know what, maybe I'll put on the knobs. I typically wait, and that's like the last thing I do, is put the knobs on after I test it. But for this video's sake, we're just going to go for it. Nothing too crazy here, just putting on the knobs. And I like to just turn all the way to the left, line up the 0 mark, and then tighten down. Simple as that. Don't have to go too crazy. And then it spins and it feels so good. So we'll do that with the rest. It looks like my battery is starting to run out, so I'm going to charge this. Oops. And there you have it. You have completed the Tone Geek Valve Screamer Classic TS10. So now go plug it in and enjoy the sweet tones. You can obviously change out the knobs to whatever you want. Actually, Love My Switches came out with the same knob as this, same look and feel, but it has a black hex insert, which, if you have an eye like me, that silver might bug you a little bit, and black would look nice. All right, so there it is. Enjoy, my friends. And you can buy this circuit board on the tonegeek.com, and it comes with the faceplate. So one last thing that I like to do is when you have your plate all done and you've confirmed that your build works, which mine does, I like to take one corner and take my drill, my step bit, and just ream out very carefully around one of these corners. And what that's going to do is when you take your screws and screw down, there's a better chance that this top enclosure is going to be grounded because the rest of this chassis is grounded, and that's going to make the top grounded. And then we have one grounded box, which is pretty sweet. Should reduce any noise and interference that way. So if yours works, congratulations, and I hope you enjoy it for years to come.